Hi there and welcome back. Let us look at a refrigeration cycle together. For this example, we are going to look at carbon dioxide refrigeration. Now, a refrigeration cycle, this means we will be routing away heat from an area we want to cool. This will be accomplished by manipulating pressure of the working refrigerant. Use of a refrigerant, usually it can be used as an air conditioner or a refrigerator. And a refrigeration cycle consists of 4 steps: compression, condensation, throttling, and expansion, also the evaporator. Now, our aim is to cool water from 12 degrees to a -0 degrees using carbon dioxide as a refrigerant. Okay, let us build our system. I am going to use Coco simulation. First things first, you want to add your property package. You can either do this by opening configuration T and adding your package. For this scenario, we are going to use carbon dioxide and water. In this case, I've already added my property package, so I'm going to connect it to my system. For our simulation, we are going to need few parameters. This include compressor, condenser, expansion valve, and our evaporator. So let us put everything on our page. We are going to need a compressor, an expansion valve. I will choose a heater cooler as our condenser. Let us use a heat exchanger as an evaporator. Since heat will be exchanged, we will be cooling water from 12 degrees to -0 degrees. So I'll choose a heat exchanger. For our streams, let us start with the stream from expansion valve to the heat exchanger. For the heat exchanger, it's important to note that inlet 1 will go along with outlet 1 and inlet 2 will go along with outlet 2. I'll connect my second stream from the evaporator to the compressor. My next stream will be from the compressor to the condenser and from the condenser to the expansion valve. We are going to cool water from 12 degrees to at least -1 or 0 degrees. So I'm going to connect my water streams accordingly. Let's label our streams. For stream 1, I'm still going to specify that stream 1, but I'll just say stream 1, carbon dioxide. This stream here will be water in. So the next step will be just to label our streams accordingly. I want to include my stream report. Let me include it here, even though there's still nothing yet involved. We are going to include the carbon dioxide stream and the water streams. Now let us fill in our streams with the values that are desired. We said we will be cooling water from 12 degrees all the way to 0 degrees. For our water streams, we can say pressure is operated at 2 bar. And for the stream, we mainly have water and 0 carbon dioxide. For the flow rate here, let us say 125. For the outlet stream, also we only have water at 125. It's also important to note that prior to this video, I did work on this example before myself and tried and manipulated the variables. So I've also figured out at what parameters, temperatures, and pressures this refrigeration cycle will achieve the desired value, which is 0 degrees at the outlet water stream. From basic refrigeration cycle knowledge, we learned that the pressure at point 2, which is this point here for me, will be the same as the pressure here at point 1. The pressure from P3 will be equals to P4, which is the pressure out of the compressor, entering the condenser will be the same as the outlet condenser stream. Let us operate the lower pressure at 27 bar and the high pressure at 60 bar. So I'm just going to put in these values. We are going to use carbon dioxide as the refrigerant. This means the entire refrigerant cycle will consist mainly of carbon dioxide. So I'm just going to edit all the streams into a mole fraction of 1 for carbon dioxide. Also, let us keep the flow rate, well, it's going to be constant at 150 kilograms per hour. Let's fill in everything accordingly. Great. Now, if we look back at our report, we are only short the temperatures. When you run the cycle for the first time, you might want to manipulate your power required or heat duty for the condenser or the power required for your compressor. Also, the outlet pressure for the expansion valve. So for the expansion valve, we are going to say we want an outlet pressure of 27, since we said those streams will be operated at 27 bar. Okay, so now for the first step, I am going to run this file. Let us see what's going to happen. Okay, it's not making sense. So I'm going to reset everything. For the condenser, we want an outlet temperature of 22 degrees. So if we said that temperature here will be 22, this means the stream will have a temperature of 22 degrees. For the expansion valve, we can say the temperature here will be at a maybe -10, ranging to -9,875. And obviously the temperature we expect it to cool as it comes down here. So it can cool to something positive. Now this temperature here, it's going to be extremely high and it's going to be influenced by the power required or energy demand used here. Let us edit that. Energy demand, we can say in kilowatts, 3.91. Let us run the file and see if everything balances. Okay, it's still not making sense. We did not cool our water to 0 degrees. It is at a positive, which is this outlet stream here, and we want to achieve a -0 or just below 1 degree Celsius. So I'm just also going to edit that again, reset. So I just entered the temperature value that we can expect at the third stream here, which is the compressor, all the way to the condenser. Next step will be to edit the heat exchanger. Edit the heat exchanger type. I'm going to change it to LMTD, which is the logarithmic temperature difference. Let us say here 450. After manipulating the condenser heat DT, we achieved 1.21 as a temperature on the outlet stream. Another thing we can do is manipulate the water flow rate to 100. Okay, now that we manipulated our water flow rate to 100 kilograms per hour, let us run our file. We can see by observing that the temperature of the water outlet decreased a lot. It went all the way to -1. Let's try and increase that to at least 110. Let's see if it's going to make any other differences. -0.2. I think this is what we wanted to achieve. We wanted to achieve a temperature of water outlet stream of -0, entering at 12. So we did cool our water all the way down to a -degree Celsius. We can also manipulate the compressor here. Let's see, we are operating at 319. Let's see if we say 3.25 kilowatts per hour, what's going to change there? Run the file. Okay, so it did affect our water outlet stream. It didn't change much here. So I'm going to take it back to where it was at, just going to say 3.20 kilowatts per hour. Run my file. Okay, great. So I'm happy with the water outlet stream. So far everything makes sense. Let us fill in our values. Okay, now let us explain our refrigeration cycle. So what we just did here, we just cooled water from 12 degrees to a -0 degrees using carbon dioxide. For step number 1, we have our compressor, which is the compression. It is operated at high pressure and at high temperature of 60 bar. The refrigerant carbon dioxide enters the compressor at low temperature and low pressure from the evaporator, and it is at gaseous state. The carbon dioxide will undergo compression through the application of compressor. This will cause the gas to heat up under the pressurization, and as a result, carbon dioxide changing into its liquid form. The second step is the condenser. The pressure at condenser and at the compressor streams, it's kept constant at 60 bar. Next step, it's step number 3, the throttling step, which is the expansion valve. The pressurized carbon dioxide will move through the expansion valve, which is the gateway into the area of low pressure. Next step is the evaporator. In this case, it's scenario we use the heat exchanger. Here we have carbon dioxide at low pressure, low temperature. During this stage, heat will be transferred and water will be cooled from 12 degrees to its -0 degrees, which is what we wanted to achieve as our aim. And obviously we use carbon dioxide as the refrigerant. I really hope this was fun and you also enjoyed solving it with me. If you have any ideas what we should solve next time, feel free to comment down or send me an email. I enjoy reading your emails. Thank you so much for watching. Till next time, bye.